Crash course on engineering. Electrical and computer engineering. Gain an understanding of electrical circuits, digital systems, and computer architecture. Sure. I am happy to provide a crash course on electrical and computer engineering. This field is an exciting area of study, as it combines knowledge of both electrical engineering and computer science. Electrical and computer engineering professionals work to design, develop, and test electronic systems, from small consumer electronics to large power grids. This article will cover some of the basics of electrical circuits, digital systems, and computer architecture. Electricity is the foundation of modern technology, and electrical circuits are the building blocks of electronic devices. Electrical circuits are essentially paths along which electrical current can flow. A simple circuit might consist of a battery, a wire, and a light bulb. When the wire is connected to the battery, an electrical current flows through the wire and powers the light bulb, causing it to illuminate. This is an example of a basic circuit, but there are many more complex circuits used in various devices. Digital systems, on the other hand, use binary signals, zeros and ones, to perform calculations and store information. Computers, smartphones, and other digital devices are all examples of digital systems. In these systems, information is processed and stored in binary format, which allows for fast and efficient computation. Computer architecture refers to the design of computer systems, including hardware and software. Computer architects work to design and optimize computer systems for specific applications, such as gaming, data processing, or scientific computing. This involves understanding the underlying hardware and designing software that can efficiently utilize it. Now that we have covered the basics, let's dive into some interesting examples of electrical and computer engineering. One example of an innovative electrical circuit is the Tesla coil. This circuit uses high-frequency AC current to create impressive electrical arcs, which can reach up to several feet in length. The Tesla coil is often used in demonstrations and exhibitions, as it is both visually impressive and relatively safe to operate. Another example of an interesting electrical circuit is the Arduino. This is an open-source microcontroller board that allows users to build their own electronic devices. The Arduino board can be programmed using a variety of programming languages, and it is widely used by hobbyists and professionals alike. When it comes to digital systems, one fascinating example is the Google search algorithm. This algorithm uses a complex set of rules and calculations to sort and rank search results. The algorithm takes into account various factors, such as the relevance of the content, the quality of the website, and the user's search history. The Google search algorithm is constantly evolving, as Google engineers work to improve the accuracy and relevance of search results. Another example of an interesting digital system is the Bitcoin blockchain. The blockchain is a decentralized, distributed ledger that records all Bitcoin transactions. The blockchain uses a complex set of cryptographic algorithms to ensure the security and integrity of the ledger. The blockchain has many potential applications beyond cryptocurrencies, such as secure data storage and transfer. Finally, let's discuss an example of computer architecture. The supercomputer is an excellent example of computer architecture in action. Supercomputers are designed to perform complex calculations at incredibly high speeds, and they are used in a variety of applications, such as weather forecasting, scientific simulations, and financial modeling. Supercomputers are designed with high-performance processors, large amounts of memory, and specialized input-output systems. Now that we have explored some interesting examples of electrical and computer engineering, let's take a look at the top 12 different electrical circuits, digital systems, and computer architecture. 1. Logic gates. These are the basic building blocks of digital circuits. They perform logical operations such as AND, OR, and NOT. 2. Transistors. These are electronic devices that can amplify or switch electronic signals. Transistors are used in a variety of applications, from audio amplifiers to microprocessors. 3. Integrated circuits. These are tiny electronic circuits that are etched onto a small piece of silicon. Integrated circuits are used in a wide range of electronic devices, from smartphones to spacecraft. 4. Printed circuit boards, PCBs. These are flat boards that contain electronic components and conductive pathways. PCBs are used in almost all electronic devices, as they provide a compact and efficient way to connect electronic components. 5 microcontrollers. These are small computer chips that contain a processor, memory, and input-output peripherals. Microcontrollers are used in a variety of applications, from home automation to medical devices. 6 Field-Programmable Gate Arrays, FPGAs. These are programmable logic devices that allow users to create custom digital circuits. FPGAs are used in a variety of applications, from signal processing to cryptocurrency mining. 7 Digital Signal Processors, DSPs. These are specialized microprocessors that are designed to perform signal processing tasks. DSPs are used in a variety of applications, from audio processing to image recognition. 8 Power Electronics. This is the study of electronic circuits that convert and control electrical power. Power electronics are used in a variety of applications, from renewable energy systems to electric vehicles. 9 Computer Networks. These are systems of interconnected computers that communicate with each other. Computer networks are used in a variety of applications, from email to online gaming. 10 Cloud Computing. This is a model of computing where resources are accessed over the Internet. Cloud computing is used in a variety of applications, from online storage to software as a service, SaaS. 11 Artificial Intelligence. This is a field of computer science that focuses on creating intelligent machines that can perform tasks that normally require human intelligence. Artificial intelligence is used in a variety of applications, from speech recognition to autonomous vehicles. 12 Quantum Computing. This is a type of computing that uses quantum mechanical phenomena, such as superposition and entanglement, to perform calculations. Quantum computing has the potential to revolutionize fields such as cryptography and drug discovery. In summary, electrical and computer engineering is an exciting and rapidly evolving field that is critical to the development of modern technology. Electrical circuits, digital systems, and computer architecture are the building blocks of electronic devices, and engineers in this field work to design, develop, and optimize these systems for a wide range of applications. Some interesting examples of electrical and computer engineering include the Tesla coil, the Arduino, the Google search algorithm, the Bitcoin blockchain, and supercomputers. The top 12 different electrical circuits, digital systems, and computer architecture include logic gates, transistors, integrated circuits, printed circuit boards, microcontrollers, field-programmable gate arrays, digital signal processors, power electronics, computer networks, cloud computing, artificial intelligence, and quantum computing. And now, as requested, here is a poem about electrical and computer engineering. Electricity flows through wires and circuits, powering devices and machines with purpose. Digital signals pulse through processors and chips, bringing to life the machines that we grip. From the basic logic gates to the complex blockchain, the innovations of engineering never wane. Transistors amplify and switch with ease, while microcontrollers bring our ideas to their knees. Computer networks connect us all, while cloud computing makes our data haul. Artificial intelligence and quantum computing push the limits of what we find computing. Electrical and computer engineering, a field of endless possibilities for inventing. A fusion of science and technology, driving us forward into the future with velocity. ******. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?8 = 7989335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.